Hello Minecrafters, and welcome to my series of videos on structured modular redstone programming. My screen name is R. Miranda. The R stands for Rob. What are my qualifications to teach redstone programming? I attended the University of Whitewater, Wisconsin, and got a degree in Management Computer Systems Letters and Sciences. The Letters and Sciences part meant I had to take 2 courses in assembly language. How did I get started with Minecraft? Some friends of mine that I met in college, their children, Heather, Ryan, and Ian, got me started. They all played Minecraft and they got me started. I started learning about redstone and eventually joined a server and eventually became an owner on that server. I'm currently located at www.emerald-nation.com. If you'd like to stop by and visit me, I'd be happy to discuss stuff with you. Now, the last question on this area is, how does assembly relate to redstone programming? Well, redstone is like assembly because it is binary in nature. It is either in an on or an off state, just like assembly bits, because assembly is a language that gets right down to the basic level of the computer. And so we're going to have to do that in redstone. Now, next question to answer here is, what is structured programming? Structured programming is a method where we use a very, very strict structure to make sure everything works correctly. If we don't use a structure, we can get a little disorganized. Assembly as a language is an extremely tightly structured language. It's very, very rigid. You can't make even the least little typo or it just won't work. Redstone is just the opposite. Redstone, you can pretty much do anything you want, and good luck. Maybe it'll work, maybe it won't, but it's really hard to troubleshoot unless you use structured programming. What is modular programming and why is it important? Modular programming is, what we're going to do is break a program down into its tiniest little chunks that we can and write a module which can do just that chunk. And if it's a module that we might be able to use in another program, we're going to save that module in a library and store it for other programs. I'll show you how to do that at another video. What is top-down design, and why do we care? Top-down design is a structure of building a game or any program where you kind of work on the first thing you need to take care of first, and move on through the rest of all the things you have to do until you get to some kind of conclusion. And you do things in the order that they occur. And that's very easy to do in redstone programming, so it applies for us, and I'll show you how that works. There are 2 types of issues we will deal with: binary logic issues and redstone issues. For example, redstone syntax errors versus logic errors. Redstone is the language that we're going to be expressing our computer logic in, and redstone has its own syntax. Anybody who's played with redstone knows you've got to lay it out just right or it's not going to work. Those are what we call syntax errors. We're also going to make logic errors, where we should have thought about it a little more and maybe we didn't reason it all out perfectly, but the redstone will have to troubleshoot logic errors as well. We'll learn how to do both of those. Now, last thing in this area is, what are binary numbers and must we use them? Binary numbers are numbers that have nothing but 1s and 0s in them, and yes, we must use them because it's really the only thing redstone can do to represent a number. So we're going to use lots of binary numbers. Last thing is, what am I going to build in this series of videos? Well, this series of videos, I'm going to build basically all the casino games I can think of. I'm going to try to make them all perfectly functional. This particular video, I'm going to build a Blackjack Machine. moving right along, it's time for the dreaded math part. You got to learn math if you're going to do binary numbers. First of all, let's talk about decimal. In decimal numbers, we have a ones column, a tens column, and so on. Each new column to the left you multiply by one more factor of 10. So if you wanted to have the number 321, the mathematical equation for it would look something like this. 1 times 10 to the 0th power, everything to the 0th power is 1, so that's just a 1. 2 times 10 to the first power, well that's 10, so 2 times 10 is 20. And 3 times 10 to the second power, or squared, which is 300, so 321. Now we do that in our heads without even thinking because we just think in terms of decimal. That's because we're human. We're not computers. However, computers and Redstone does everything in binary. We do it exactly the same as in decimal, except instead of having tens, we have twos. And instead of being able to put the digits 0 through 9 in the first column of the equation, we can only put ones and zeros in this column here. So let's just say that the binary number we have is 111. That would be 1 times 2 to the 0th power. Well, anything to the 0th power is 1, so 1 times 1 is 1. Plus 1 times 2 to the first power. Well, 2 times itself 1 times is exactly 2, so that's a 2. And the third one is 1 times 2 squared. 2 times 2 is 4, so that's 4 plus 2 plus 1 is 7. Minecraft does numbers in binary, so we're going to have to do so as well. How do we implement binary numbers in Redstone? Well, this is a binary number storage cell. It's a single bit storage cell. It can store the numbers 0 and 1. I'd just like to read through these signs real quickly here so we don't forget anything. This is a 1-bit memory cell. It can store either a 0 or a 1. That state is stored even if you exit the game. Either side of the memory cell can be considered to be the on state. We can change the state of the memory cell by any input to the off side of that memory cell. We can read the state by any output from either side of the memory cell, but generally we choose one side of the cell as on. I'm going to demonstrate. Just for fun, I'm going to say that this side, which is currently off, is actually our on state. We don't care about anything unless this is on. This is the off state. This button, which turns it on, is the on button. Now we can say that this memory cell is in the on state, or it represents the number 1. This button then becomes the off button, and it goes off. Okay, before I wrap this little video up here, I'd like to mention that this series of videos that I'm making here uses no mods of any kind. So you don't need anything to do this. All you got to do is follow my methodology. And the next question I'm going to be covering in my next video is how do we do numbers larger than 0 or 1? Find out in the next exciting episode, and thank you for watching.